Hello everyone, welcome to the community of Codezilla. Myself, Jayan, I'm a technical member in the club Codezilla. Today we discuss statistics with Python. Without late, let's dive into statistics. Statistics is nothing but the way we visualize and analyze the data in an efficient manner. Uh, Data is majorly classified into two types, quantitative data and qualitative data. Quantitative data is nothing but the variable that have a numerical value that we perform mathematical operations on them, like BMI, income, and getting a head when probability of a head by flipping a coin. And quantitative data was classified into continuous and discrete. Continuous data is of a floating data or an intervals of any values, and the discrete data is nothing but a countable values or a finite number. Qualitative data or categorical data is a type of data which categorizes a single value or an item into a particular group as we assign based on the parameters. And it was further classified into ordinal and the nominal. Ordinal data is keeps the point on taking ranking the data and order the data. And the nominal data is nothing but a group names and it doesn't follow any ranking. The better ways to represent data depends upon the data which we take to visualize the data. Yeah, quantitative data was suits to fit in the histograms, and categorical data was able to measures and visualize in table, graphs, and pie charts. Histograms were basically described on the four parameters: the shape, whether the histogram is symmetric or bell shaped or right or left skewed data. Center of histogram is a mean or a median, and the spread of histogram is nothing but how far the data spread. And with the help of that, we can find the range, interquartile range, standard deviation, and the variance. Outliners are nothing but data points that fall far from the bulk of data. Uh, in these four parameters, we will describe the histogram. Simple statistics. We measure the simple statistics like a mean. Mean is nothing but average of all the data. And median is of a centralmost value where the data is arranged in ascending or descending order. And quartiles. Quartiles are nothing but a Q1 is equal to 25th percentile of the data, and Q2 is equal to 50th percentile of data, Q3 is equal to 75th percentile of data. It's all about the dividing the data. Range is nothing but the difference between the maximum and minimum observation. And interquartile range is of the difference of extreme value, extreme quartiles. Standard deviation is nothing but how the deviation of observation from the mean. Why we use Python? We use Python because it is simple to code and it has huge number of libraries and high level language, and it takes less time to compile. Before going to a Python code, let's look into a beautiful another data representation entity, that is boxer plot. Boxer plot gives all the essential stuff of statistics in a single graph. Like the yellow strip shows a median, and the width of the box will shows the interquartile range, and width and the edges of the box shows the quartiles, and the extreme value shows the minimum and maximum, and the outliners would describe a small dots like structures. Okay, now let's code. We import the data essential libraries like NumPy, Pandas, Matplotlib, and Seaborn. Yeah. Now I'm using a default data set to visualize the data. I'm using a Seaborn package to load the data, and I'm assigning the loaded data to the variable name data. Because it is easy to access in each and every time when we need it. And to get the first 5 rows of the data, we use the data.head command. Like see, the data is about restaurant data, how the restaurant works, and how many customers it works, and how many bill was going on, and what the tip was given by the customers, and it's all about restaurant data. And I'm using numerical Python to get the basic stuff of statistics like mean, median, and standard deviation. These are the commands, and when we execute, we get in a simple and easy manner the mean and the median as well. And here we are using only the one column, that is total bill, a column to get the standard mean and median. If you like, we can also use a tips column to also get the mean and median of this tips, how much tips they get. And we use a percentile, if you want Q2, we can use like a 50, and we can write we can again change like this, and we get that. And we can get the minimum and maximum values to get all the rows which are able to get mean, median, and enough data. We can use data.describe function to get all the stuff of data, like how many, you see, like how many rows were there. It's all of 244, and what was the mean of tip, what was the size of the party, and all we can get here with the help of data.describe function. Now it's time to visualize the data. I'm using Seaborn to design a graph, and matplotlib to show the plot. Here I'm using total bill column to visualize the data with the help of histograms. Like that, we get a histograms of total bill was paid by the customers during in the data set. And as we change this value to true, we get the shape of the data. The histogram is of a bell shape or symmetric shape. Now this is a symmetric histogram, somewhat, we can say. Sorry, it's a slightly right skewed data. And now we can see in the same manner, we can see the data set of tips data set, and we can compare with the help of both data sets. Like the tips data set, it's all about 0 to 10, and the total bill made was of around 6 to 55 or something approximate, we can say that. And the last one, we can see the box plots of total bill with the help of this code. See the box plot of total bill, and the box plot of this tips was given here. We can measure the median is of 17. We can, if you have any doubt, you can cross check with the with our data which was given by that. It's very simple. Now I use the data set to get the box plot of data tips data set with the day, with a particular day, how many we can describe that how many tips was get, how much tip was get on a particular day. We can use this code like this. How much code is we can see that we get a good mean, like we get good mean on Friday. See, we get a Friday more mean on Friday and Sunday, we can say. And we can get an each and every histograms for that. It's all about a simple statistics. If you're interested to interact with us, you can